Hi, welcome back to my channel. In this video, this video will be a very short demonstration regarding data transformation. Since we all know that the essence of experimental design is based on a very important algebraic procedure that is known as analysis of variance. And this analysis of variance is usually based on certain kind of assumptions, rather we can say certain kind of conditions. And one of the important assumption is about the residuals, or we can say the errors, that they should be normally distributed rather independently and identically distributed. When I say identically distributed, that means there should be an existence of homogeneity of variances. And when I say independently distributed, there should be a non-existence of correlation among the consecutive error terms. So normally this is a protocol, this is a condition which we have to fulfill. If these conditions or these assumptions are not fulfilled, then we have to do certain kind of adjustment, and it depends upon what kind of objectives, what kind of variables, or what kind of units in your variables are involved. So if we are not in a position to fulfill these kind of assumptions, then we have to do certain kind of adjustments, and in statistical terms such kind of adjustment is known as data transformation. So as far as this data transformation is concerned, we have three different transformations. One is log, then square root, and the third one is angular or arcsine transformation. As far as this log transformation is concerned, it is usually used when we have a huge range, existence of a huge range in our data set. For example, if we take a vector first here, its range is from 0 to 1000, so there's an existence of a huge range. So whenever there's a huge range present in your data, then you can go for log transformation. Let us run this. Let us see. Run. So could not find the function here. For that you have to recall a library, doebioresearch. Then let us run it again. So we have the log transformed values. You can see it is usually used. So simply the function is log transform. This is the simple, or you can simply create a vector of your own. You can write anything. Let us create a vector. Instead of this opposite arrow sign, which is usually known as assignment operator, you can write is equal to, then C is the concatenation function which usually combines all these things. Then let us write 20, 40, 90, 5, then enter. Then if I will write log, then transform, then I will click on this, then I will write here the vector. So I'll be having the transformed values, or the log transformed value of all these observations. Then we have two another transformations, another one that is square root and arcsine. As far as these square root transformation is concerned, it is usually used whenever both of these transformations, actually square root as well as arcsine, they are used when we have a data which is present in percentage. For that I will use a one slide PPT here. You can see if our data, since we have a choice, we have three different types of transformation. One is log, square root, and the third one is arcsine. So first one is used whenever we have a huge range of present in our data, and this square root and arcsine is usually used when the data is present in a percentage form. And for that we have a choice. For percentage data which lies in the range of 30 to 70, we don't need to do any kind of transformation. But if the percentage data lies within the range of 0 to 30 or 70 to 100, but not in the both extreme, then square root transformation can be implemented. And if we have a data which isn't present in the which is also in which is not present within the limits of 30 to 70, or we can say for a percentage data that do not follow the range specified in rule 1 and rule 2, then angular or arcsine transformation can be used. That means if our data falls in the range of 0 to 30 as well as 70 to 100, or some say 20 to 80 also, some researchers consider 20 to 80 as a normal range also, but majority of the times you will see 30 to 70 is considered to be a normal range. Or we can say if you have a percentage data which is in the range of 30 to 70, it is assumed to be normally distributed. And if our data lies in the range of 0 to 30 or 70 to 100, then we can apply square root, but not in the both cases. If our data is present in the both extremes, or it lies in the both extremes, then we have to use angular or arcsine transformation. So if I will create a vector here, like vector is equal to C, then within this concatenation function, let us write 34%, say for example 25, anything you can write, it depends upon what kind of data set you have. Then I will write 60.6. Then in order to perform the square root transform, I will write sqrt. Then I will write square root transform here. It actually creates, this function carries out the square root transformation of a particular vector. Then I will write vector. So I have the square root transformed values of all these original values. Then in order to perform this angular transformation, let us suppose we have a vector here. Let us run it. Now in order to recall this and in order to implement this, we have to write this function arcsinetransform. Then we have to write the name of the vector which we have given, or it might be in columns. You might have created a data frame also. Then here what we have to do, we have to write two things. One is 0 and another one is 100. So you can see the arguments here are the 0 if data is in percentage. If our data is in percentage, then we have to write an argument after this vector. This is 0. Then we have to write this n, it stands the number of units. If I will write here 1, that means our data is present in proportion, so we have to be a bit cautious here. So let us run it. Since we are assuming that our data is in percentage, that is why here it is 0. You can see if 0 stands for percentage data. If it is not in percent, if in proportion, then we have to write 1 here instead of 0. And this 10 is nothing. These are 10 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have 10 observations. But another important thing is that whenever you are having a data which is in percentage and you are in a position to fix that, we have decided that you have to apply arcsine transformation. If some of the observations in your data set is 0 or 100, then you have to replace that 0 by 1 by 4n. N is the number of observations, and 100 by 100 minus 1 by 4n. Similarly, in case of square root transformation or square root transformation, if some of the percentage values are less than 10, then you have to add 0.5, 0.5. For example, if some value is 9.5%, then what you have to do before doing the transformation, square root transformation, you'll simply add 0.5 to this 9.5 value, then do the transformation, then apply the square root. Or simply if any value is less than 10%, then what you have to do, you will simply write square root of x plus 0.5. So this is very important. The idea behind this transformation, data transformation, is actually to stabilize the variance. So this is one of the important assumptions as far as the analysis of variance is concerned. So whenever we are applying analysis of variance, we have to check the assumptions of these errors or residuals. If they are not fulfilled, then we have to do these kind of transformations. All these three can be implemented, depends upon what kind of units you are having the variables in variables, or what kind of range, whether your data is in percentage, in proportions, or you have an existence of a huge range in your data. Then you can apply all these kind of transformation, and the idea behind this transformation is to stabilize the variance. But even if after this transformation your data is not normalized, or we can say the data does not follows the normal distribution, again they are not independently or identically distributed, then you have to do the alternative procedure of this traditional statistical procedures, which are parametric in nature. Then you have to use the non-parametric test. For that I will be making a separate video. So thank you very much. Hope you will like this video.